Hey everyone, today we're diving into requirements-driven software design. It's your fluff-free playbook for small TypeScript web apps.
So, what's the biggest risk for small teams? Over-engineered microservices and fragile framework-specific hacks. Let's avoid that trap.
The cure? A unified vocabulary. You literally use the exact same language from raw requirements right down to automated tests.
Here's our roadmap: requirements, complexity, the coupling yardstick, minimal architecture, testing, and finally, system evolution. Let's jump in.
Chapter 1 covers requirements as design input. Translating requirements isn't just coding, it's building verifiable agreements with your team.
Treat requirements as strict promises and specifications as observable behaviors. This strict separation kills ambiguity right out of the gate.
Moving to Chapter 2, reading complexity. Look, code volume doesn't drive complexity. It's actually all about interaction and impact.
Ditch the gut feelings. Mechanically identify complexity by writing change scenarios, enumerating the impact, and determining your observation points.
Chapter 3 introduces the coupling yardstick. We need an objective way to prioritize and measure our architectural decisions. Measure coupling objectively through integration strength, distance, and volatility. These metrics tell you exactly where to fix architectural boundaries. Chapter 4 is all about minimal architecture. Create the absolute minimal boundaries needed to keep small TypeScript apps fast. Separate your pure functional core from a thin shell that handles I/O. And remember, never push state inward.
Structure your app using domain, use cases, and adapters. Safely pass data transfer objects across these lines without mixing concerns.
Chapters 5 and 6 tackle pragmatic testing. So how do we actually verify this minimal architecture we just built?
Simply align test types to specific boundaries. It proves that sheer test volume matters way less than targeted value.
Let your metrics dictate your test. High volatility demands unit tests, while high distance requires integration tests for contracts.
Finally, Chapter 7, managing system evolution. How do we objectively know when it's time to upgrade our architecture? Simple. We don't guess. We wait for measurable degradation in our metrics to trigger an architecture decision record.
And an ADR doesn't need to be a novel. Just capture the context, decision, and consequences. That's it.
I'll leave you with this. Are your tests actually proving your requirements or just testing your code? Think about it.